Hello, my name is Sofyan. Today I will explain about case RT1A, case RT1B, and case RT2. First, we have case RT1A here. Case RT1A is about task scheduling and periodic tasks. Case RT1A specification is to design an embedded system that writes every second to the terminal an increasing number, and when idle is running, writes a point. Now we will see the code that we use on the NIOS 2 to implement case RT1A. On this case, we will use case Gold hardware to simulate in FPGA board. I will explain about the software from Sierra IP. On the C file, there are 4 Sierra device driver, hardware base address, and C library. Here we have task configuration. To create the task, first is to define the name of the task in the beginning of C code, and every task has on stack. Here we define idle and timer task. And first we have timer task code here, and then we have idle task. Idle task is always on the system. When CPU does nothing, the idle task executes. In this code, the idle task will print as a dot. Now we will jump to the main code. In this line is to initiate Sierra hardware, initiate variable, interrupt, and TCB. And then next to line is to print the version, software, and hardware which are used. And next step is to define the clock tick in the system. And this one is to create the task, idle and timer task. And the last step is to start the system. Next, we will compile and run the program on the card. As we can see from the console, the dot will print when the task is idle, and the incremental number will print every time a task executed. The task with the highest priority will always available to run to the CPU. That's all from the case RT1A. On the second case, we have case RT1B. In this case, we will activate the logic to get more information about timing. To activate the logic, first we need to open the file Altera Avalon Sierra Care. Here we have already opened it, and we need to define dev logging print. As we can see here, already defined. And then we can compile and run run in hardware. As we can see from console, when it's running, there are two different types information show. First is preemption. The higher task in ready queue push out to the running task the new task ID and timestamp print here. And the second is the next task. It's a soft change of task, the next running task, and the time stamp prints. Time resolution for time is about 163 microseconds. With the logging, we can get more understanding how the system works. That's all from case RT1B. Next, we will continue with case RT2. The specification for this case is to create two more tasks. The task with the shortest period time obtains the highest priority. In the configuration file, we need to add a new two tasks, task number 2 and 3, and also task here. And then if we jump to the main code, task with the shortest period time is the highest priority. Now we will compile and run in hardware. In the NIOS to console, as we can see, the timer task 10, which is the highest priority, executed first. After 1 second, then the timer task is executed. There is the idle task executed between, and this process repeat until 10 seconds. The timer task is executed. And what if we increase the extra virtual load here, and let's see if we can compile and run the hardware. If we increase the virtual load on one or more tasks, the period time can be missed, as we can see. That's all the presentation of case 1A, 1B, and case 2. Thank you.